Hello and welcome to another, or first maybe in this case, video. This is going to be a series looking at malware analysis, and the way I wanted to split this up is each video will have a separate payload or separate section of payload, meaning each time a sample reaches out to another resource or deobfuscates itself or does something beyond the plain lines of text you see on the screen, will be a separate video. Hopefully this will make it a bit more bite-sized at the expense of fragmentation. The main two purposes I want to get across in this series is methodology and detection content. So methodology of how I kind of make the decisions I do, my thought process and tools I use, and then also secondary, identifying odd behavior we see in the samples, and then how you might be able to transcribe that behavior into detection content beyond simple searching for hashes or IP addresses or domains, things which are suitable for the same sample being seen again with different attack infrastructure. So without further ado, we're going to have a look at this sample here from Malware Bazaar. This is KoiLoader, which I'm not going to go too much into detail about yet. That will be a follow-up video. But for a start, I just wanted to download the first sample, this one here, which I'll put the hash in if you want to find it yourself, and then just get started. So I've already downloaded it. It's simple as just extracting it. I'm just going to overwrite the one I've already got. Password is infected, and then we can load the sample here. So this is what it looks like when you just load it in a text editor. This looks like JavaScript to me. And what we can do, or what I have done, is basically split this apart into each consecutive like, not even necessarily line, but statement, to make it as easy as possible to understand what's going on. Because the purpose of this isn't really just to say, okay, this looks malicious, let's block it and move on. Because doing that, obviously, you potentially block further infections, but you're not able to identify behavior on other hosts which may already be infected. You just haven't seen alerts for yet. And similarly, if the attack infrastructure changes, so if the source of this file changes, if the TTPs change, or not even if the IOCs change, then this simple block and a cleanup isn't going to work. So here is the first stage. Essentially, I've explained it section by section. And we'll start off with the first line. So this is creating a variable called AOJ, which is a new ActiveX object to be script.shell. Now, essentially, this is kind of using the legacy ActiveX library, I guess, is the best way to describe it, which isn't actually used on modern browsers. So if I go back to my sample here, and I just run F12, and I take this one line, paste it into the console, try to run it, I'll get an error because it is not defined. Essentially, this means that when that's a pigeon, when the attacker was writing this, either purposefully it was being targeted at an IE environment, Internet Explorer, or perhaps they just copy-pasted code from some of the sample, or they weren't really sure what they were doing, and it means this wouldn't affect, because the very first line wouldn't even run, let alone anything else, on modern browsers. But assuming you still have Internet Explorer in your enterprise, let's carry on. So this is basically saying this variable AOJ, which is defined as this. Didn't mean to do that. Control Z. That dot run, and then that is running PowerShell, and this is a PowerShell command essentially. Invoke web request, that is kind of the alias, I believe, for invoke web request, and then use B is just use basic parsing. So then it's basically making a request via PowerShell to this PHP page, and then this will be tacked on, but I've separated it out just for the sake of clarity. Out file, so this is basically saying save this content to a temporary folder. So this is just the env environment variable for the temp folder, and it's calling it this.js. So essentially, to summarize so far, generates a shell which runs PowerShell that uses invoke web request, use basic to download content from here, and then save it to your temporary folder here called that.js. Then you are deleting a scheduled task, and the task name is the first argument of wscript.argument. Well, the first argument of wscript. It's not entirely clear why it's doing this. Presumably, if it's deleting a scheduled task, this means that this isn't the first part of like a malware chain. This is probably maybe the second or potentially third phase or stage more specifically. So if this was, let's say, an email, there might have been some JavaScript in the email which pulled down this file from wherever this was hosted, and that initial JavaScript created a scheduled task, and this is just deleting it. And then what we're doing is finally we're just running this file. So it's been saved in this temporary folder, and then it's just being ran by wscript run, and then this zero argument is essentially saying, or flag, not argument, sorry, this zero flag is saying it is hidden, so it's not creating any windows, where if malware usually, well not usually, if malware creates windows, like a little command, like prompts that pop up, Usersoftly usually will report this to the IT or security team. So this is kind of just a way to stop users from being aware of what's happening on their machine. So this is the entirety of the first section. But what I will do is briefly have a look at this. So if we load up URL scan, which is a really good tool for basically navigating or viewing the content of a site without going to it yourself. I'm in a VM, so it's going to be stairs, all right. So it's going to ask me to do the capture. Bear in mind, if this was, I was doing actual dynamic analysis, I would have the internet turned off, but for this purposes, I don't. So it looks like this is this IP, is that Italy? I think that's Italy. I'm bad with flags. But it looks like it's actually given a forbidden. So that means this script wouldn't run. Now, this is seen a lot of the time where maybe this is a campaign that was running a few days ago or even a week ago, and now the attack infrastructure has either been taken down by the site admin. Looks like it was a compromised WordPress website based on WP content, which is part of the WordPress CRM. But what if we want to see what would have been downloaded? So let's say we have a report of an email, maybe it was a Friday, but the user didn't report it to the security team until the Monday, and over the weekend the attack infrastructure has gone down. But we want to see what would have happened on the user side for this website if we have, if it was a Friday, so it was a couple of days ago. There is a way of doing this, just using URL scan. So if you just go to the show scans 29, and this is all the scans. So what we want to see, and you can probably see it down here, is a 200, which quite simply, if we just were, for this case, what we can do is just basically Control F, and then, so this is also 300 from 2 days ago. 3 days ago, it is giving also a 403, also a 403, still a 403. So just keep scanning through, and then eventually you can see a 200. But let's say there was, rather than 29 scans, there was a few hundred, maybe a couple of thousand. Doing it this way isn't the best. So what you can do is use the if you go to the help, it allows you to essentially do conditional searches. There is a full guide on this, but I believe it is page.status. It is 200, which I've done here before. So if you use this in your search, we only get back the 200 responses. So HTTP, okay. Oh, that's not very. So if you just for the those of you who aren't aware of what this is, when you send a HTTP request, you can either using get head post trace. Okay, essentially this means it is a successful response you're getting, whereas a 403, which you can scroll down here, is forbidden. So basically, the servers refuse to give you the content from the request. Essentially, no content comes back from the server. So if we go back to here and we find this 200 based on our new search, and then we search for the PHP file, we get the content. So if we go to DOM, this is essentially the next stage. Now, I'm not going to go through this now. That will be the next video. And spoilers, you can probably see there's yet another stage after that as well. And there's this one here. So there's quite a few different elements of this, and we'll just tackle them one by one. But this is the start. The main things to get across is using kind of the advanced searching here. This is really handy. You can also do regex. You can do quite a few. There's the API reference here, which you can go to, which gives you all the different fields. So if you wanted to look for that particular file name, there's a better one. So in this previous one, if I do, here's one I created earlier actually. Rather than have to look for it at all, I can just do page status 200, and then file name is the PHP file name, and then I just get back the 3 which I want, so the 3 from 4 days ago. So this is a really good way of basically filtering down URL scan requests. And then the other thing that I really wanted to highlight in terms of methodology is just taking each constituent part and then basically trying to understand what is everything doing. So what is the ActiveX object, and does it affect our environment? If we already know, then it's not going to run because of the host. Let's say this tried to execute on was running it in Edge. So let's say we see the script trying to run in Edge, it wouldn't have executed, and we don't have to be so concerned potentially. There's still things you'd want to investigate as well, but at least we know the rest of this wouldn't have executed, which you could confirm by looking at the kind of the browser history for this second phase. The other thing is being able to pick out the fact that it's deleting a scheduled task which isn't being created. Therefore, we know it can't be the first step. Something must have created that in the first place, because it's not just a generic scheduled task, it's the arguments of Dubia script. So it has to have been created previously. And then finally, what could we do for detection content? So one of them would be basically active. Let's say we did have Edge in the environment. So a browser. So browser in that case it would be not Edge, i.e. spawning ActiveX objects, or using ActiveX objects to spawn a shell. which then runs PowerShell. That is something that you might want to have detection content for. Other things would be potentially deletion of scheduled tasks. So delete TN, and then where maybe the deletion is not asking for confirmation. So just looking for this, and then the task name could be kind of anything, a wildcard in there. This might be very noisy. I've not tested for this, but if it isn't in your environment, it could be worth creating that for. And then again, another one would be wscript running a JavaScript file from temp or TMP. So again, with no window. So this is the third one here. So these are 3 use case detection ideas. So just based off this, we've got 3 different things we could look into. Like I say, maybe these are too many false positives in your environment. So maybe they're not going to be useful, but all of these are not dependent on any IOCs. And if they are kind of rare events, so let's say this kind of chain of activity is not seen before, and you could even make it more specific where it saves, which saves a .js file. This kind of string of activity, if that is rare, then that would be a fantastic kind of piece of detection content which would catch this. Similarly with this, like if we're not seeing scheduled task deletion in the environment much, maybe based on kind of the user, you could also look at that. So what user context was this done under? It would be the user themselves. So rather than, let's say, scheduled tasks that are only ever deleted by NT authority system, if they've been deleted by the user, and that's something you don't generally see in your environment, then again, this could be a good piece of detection content. At the expense of waffling, I'm going to cut it short there, but hopefully this was useful, and then in the next video we'll have a look at what exactly this is doing. Thank you, and goodbye.